Question 1. System analysis indicates that users are intermittently experiencing one-way audio on Cisco IP phones. The issue is not tied to a specific phone model or location, and it occurs randomly throughout the day. Network diagnostics show no widespread packet loss or high latency on the core network segments. What is the most effective initial troubleshooting approach to isolate the cause of this intermittent one-way audio problem? Option A. Perform a factory reset on all Cisco IP phones exhibiting the one-way audio issue. Option B. Immediately reconfigure the audio codecs on all affected Cisco IP phones to a different standard. Option C. Focus troubleshooting efforts solely on the physical cabling and power supply of the affected Cisco IP phones. Option D. Analyze quality of service, (CoS), configurations on network devices, and examine RTP stream quality metrics within Cisco Unified Communications Manager, (CUCM), traces for affected calls. The correct answer is D. Analyze quality of service, (CoS), configurations on network devices, and examine RTP stream quality metrics within Cisco Unified Communications Manager, (CUCM), traces for affected calls. Explanation. Scenario analysis. This scenario presents a common but challenging troubleshooting situation in IP telephony. The intermittent nature of call quality degradation, specifically one-way audio, makes it difficult to pinpoint the root cause. The challenge lies in the distributed nature of IP telephony components, endpoints, network infrastructure, call control servers, and the potential for issues to arise at any layer of the OSI model. Furthermore, the impact on user productivity and business operations necessitates a swift and accurate resolution, adding pressure to the troubleshooting process. The need to balance immediate resolution with thorough investigation to prevent recurrence is paramount. Correct approach analysis. The correct approach represents best professional practice because it follows a systematic, layered troubleshooting methodology aligned with industry best practices for network and voice troubleshooting. This approach prioritizes isolating the problem to a specific component or layer before moving to the next. By starting with the physical layer and connectivity, then moving to network layer issues, IP addressing, routing, (CoS), and finally to application layer concerns, SIP, RTP, codec negotiation. It ensures that fundamental issues are ruled out first. This methodical process is efficient, reduces the risk of overlooking critical problems, and is often implicitly or explicitly supported by vendor best practices and troubleshooting guides, which are the de facto regulatory framework for Cisco certifications. This approach minimizes disruption and maximizes the likelihood of a permanent fix. Incorrect approaches analysis. One incorrect approach involves immediately assuming a configuration error on the Cisco Unified Communications Manager, (CUCM), without verifying network path integrity. This fails to adhere to the principle of starting with the most fundamental layers. Network connectivity and quality are prerequisites for any application-level communication. Failure to check basic network health could lead to wasted time reconfiguring CUCM when the actual problem lies in packet loss or latency on the network. This could be seen as a failure to exercise due diligence and could lead to unnecessary system changes, potentially introducing new issues. Another incorrect approach is to focus solely on the end-user device, phone, and its immediate configuration. While endpoint issues can cause one-way audio, this approach neglects the possibility of upstream network problems or issues with the call control signaling. If the network path is degraded or the SIP signaling is being mishandled by a network device, simply rebooting or reconfiguring the phone will not resolve the underlying issue. This approach is inefficient and can lead to a prolonged outage, impacting user productivity and potentially violating service-level agreements if applicable. Ethically, it represents a failure to provide a timely and effective resolution due to an incomplete troubleshooting process. A third incorrect approach is to randomly change CoS settings across the network without a clear hypothesis or baseline. CoS is a critical component for voice quality, but misconfiguration can exacerbate problems. Without understanding the current CoS implementation and identifying specific packet drops or queuing issues related to voice traffic, indiscriminate changes are likely to be ineffective and could even worsen the situation. This demonstrates a lack of analytical rigor and a departure from a structured troubleshooting methodology. Professional reasoning. Professionals should adopt a systematic OSI model-based troubleshooting approach. This involves 1. Understanding the reported problem and its scope. 2. Gathering initial information, e.g., affected users' time of occurrence specific symptoms. 3. Starting at the physical and data link layers, verifying cabling port status and VLAN configurations. 4. Proceeding to the network layer, checking IP connectivity, routing, and subnet masks. 5. Investigating the transport layer, examining TCP/UDP port reachability and firewall rules. 6. Analyzing the application layer, focusing on call signaling, SIP/SCCP, media, RTP streams, codec negotiation, and call control server status. 7. Specifically for voice, paying close attention to quality of service, CoS, configurations and their impact on voice traffic. 8. Utilizing diagnostic tools such as ping, traceroute, packet captures, e.g., Wireshark, and Cisco-specific tools, e.g., show commands on network devices, CUCM trace files. 9. Formulating and testing hypotheses at each layer before moving to the next. 10. Documenting findings and actions taken. This structured approach ensures that all potential causes are considered logically, leading to a more efficient and effective resolution, and preventing recurrence of the issue. Question 2. The audit findings indicate intermittent call quality degradation, including dropped calls and robotic audio, affecting a subset of Cisco IP phones within the enterprise network. The IT team has been tasked with identifying the root cause and implementing a permanent resolution. Which troubleshooting approach best aligns with industry best practices for resolving such issues in a Cisco IP telephony environment? Option A. Analyze the power supply units of the affected IP phones to rule out any potential power fluctuations as the cause of the audio degradation. Option B. Focus solely on replacing the network interface cards, NIC, in the affected IP phones, as this is a common hardware failure point for network connectivity. Option C. Systematically verify quality of service, CoS, configurations on network devices and IP phones, ensuring appropriate prioritization and marking of voice traffic, and then examine relevant call signaling and media path logs for anomalies. Option D. Immediately initiate a mass firmware upgrade for all affected Cisco IP phones, assuming a software bug is the most probable cause of the call quality issues. The correct answer is C. Systematically verify quality of service, CoS, configurations on network devices and IP phones, ensuring appropriate prioritization and marking of voice traffic, and then examine relevant call signaling and media path logs for anomalies. Explanation. The audit findings indicate a recurring issue with call quality degradation on specific Cisco IP phones, impacting user productivity and potentially violating service level agreements, SLAs, with external clients. This scenario is professionally challenging because it requires a systematic troubleshooting approach to isolate the root cause from a multitude of potential factors, including network congestion, device configuration, codec issues, or even environmental interference. The pressure to resolve these issues quickly, while ensuring compliance with internal IT policies and potentially external service standards, adds to the complexity. The correct approach involves a methodical, layered troubleshooting process, starting with the most probable and easily verifiable causes. This aligns with best professional practices by minimizing disruption, efficiently allocating resources, and ensuring a thorough investigation. Specifically, examining quality of service, CoS, configurations on the network infrastructure, and the IP phones themselves is paramount. Verifying that voice traffic is prioritized correctly through mechanisms like DSCP marking and queuing is a fundamental step in ensuring reliable IP telephony. This directly addresses the potential for network congestion to impact voice packets, which is a common cause of call quality issues. Adhering to Cisco's recommended CoS best practices and documentation ensures that the implemented solutions are robust and scalable. An incorrect approach would be to immediately replace hardware without a proper diagnosis. This is professionally unacceptable as it is inefficient, costly, and fails to address the underlying issue if it lies within the network configuration or software. It bypasses the critical diagnostic steps required to identify the true root cause. Another incorrect approach would be to solely focus on the IP phone's firmware without considering the network path. While firmware can play a role, call quality degradation is frequently a symptom of network-related problems, and neglecting the network infrastructure would lead to an incomplete and likely ineffective troubleshooting effort. This failure to consider the entire communication path is a significant professional oversight. The professional decision-making process for similar situations should involve 1. Clearly defining the problem and its impact. 2. Gathering all relevant information, logs, user reports, network topology. 3. Forming hypotheses about potential causes. 4. Systematically testing these hypotheses, starting with the most likely and least disruptive. 5. Documenting all steps taken and findings. And 6. Escalating or seeking further expertise if initial troubleshooting is unsuccessful. This structured approach ensures that solutions are effective, efficient, and justifiable. Question 3. During the evaluation of intermittent audio degradation on Cisco IP phones, which troubleshooting approach best aligns with a systematic and efficient resolution process, prioritizing foundational network checks before complex call signaling analysis? Option A. Begin by examining the IP phone's configuration files and call signaling logs for any anomalies related to codec negotiation or session initiation protocol, SIP messages. Option B. Systematically reboot all affected IP phones and the Cisco Unified Communications Manager to rule out transient software glitches. Option C. Verify physical connectivity. Check basic IP network reachability to the Cisco Unified Communications Manager, CUCM, and confirm quality of service, QoS, settings on relevant network devices. Option D. Immediately initiate a packet capture on the network segment where the affected phones are located to analyze real-time media streams for jitter and packet loss. The correct answer is A. Begin by examining the IP phone's configuration files and call signaling logs for any anomalies related to codec negotiation or session initiation protocol, SIP messages. Explanation. The scenario presents a common challenge in IP telephony troubleshooting: intermittent call quality issues that are difficult to reproduce and diagnose. This difficulty is amplified by the need to adhere to specific Cisco troubleshooting methodologies and potentially internal organizational policies for incident management, which are implicitly governed by the need for efficient and effective service restoration. The professional challenge lies in systematically isolating the root cause without disrupting ongoing services unnecessarily, while also ensuring that the troubleshooting steps taken are documented and justifiable. The correct approach represents best professional practice because it follows a structured, layered troubleshooting methodology, starting with the most likely and easily verifiable causes and progressing to more complex ones. This aligns with the principles of efficient problem resolution and minimizes the risk of introducing new issues. Specifically, it prioritizes checking the physical layer and basic network connectivity before delving into more intricate IP telephony configurations or application-level issues. This systematic approach is crucial for meeting service-level agreements, SLAs, and maintaining user confidence, which are implicit professional obligations. An incorrect approach that focuses solely on advanced call signaling analysis without first verifying basic network health would be professionally unacceptable. This is because it bypasses fundamental troubleshooting steps, potentially wasting valuable time and resources on complex issues when a simple network configuration error or physical connectivity problem is the actual cause. This failure to follow a logical troubleshooting hierarchy can lead to prolonged service outages and a breach of professional duty to resolve issues promptly and efficiently. Another incorrect approach, such as immediately replacing network hardware without sufficient diagnostic evidence, is also professionally unsound. This is a costly and disruptive action that lacks a data-driven basis. It demonstrates a lack of analytical rigor and can lead to unnecessary expenditure and further service degradation if the hardware is not the actual fault. Ethically, it represents a failure to exercise due diligence and responsible resource management. The professional decision-making process for similar situations should involve 1. Understanding the reported symptoms thoroughly. 2. Consulting available documentation and known issues. 3. Applying a layered troubleshooting model, starting from the physical layer upwards. 4. Gathering and analyzing diagnostic data at each step. 5. Documenting all findings and actions taken. 6. Escalating or seeking further assistance when a roadblock is encountered, with clear justification for the escalation. This structured approach ensures that troubleshooting is efficient, effective, and defensible. Question 4. Quality control measures reveal that users are experiencing intermittent audio dropouts on Cisco IP phones across multiple sites. The issue is not constant and appears to occur randomly during calls. The IT support team has received several reports over the past week. What is the most effective initial troubleshooting approach to diagnose the root cause of these audio dropouts? Option A. Focus exclusively on analyzing the Cisco Unified Communications Manager, CUCM, call detail records, CDR, for any anomalies. Option B. Immediately replace a sample of the affected Cisco IP phones, assuming a hardware defect. Option C. Begin by verifying the physical connectivity and basic network health of the affected IP phones and their immediate network infrastructure. Then examine relevant CUCM configurations and network CoS settings. Option D. Randomly adjust quality of service, CoS, parameters on the core network routers without first gathering specific data on packet loss or latency. The correct answer is B. Immediately replace a sample of the affected Cisco IP phones, assuming a hardware defect. Explanation: scenario analysis. This scenario presents a common yet challenging troubleshooting situation in IP telephony. The intermittent nature of call quality degradation, specifically audio dropouts, makes it difficult to pinpoint the root cause. The challenge lies in correlating user-reported issues with network performance metrics and device configurations, especially when the problem is not consistently reproducible. A thorough, systematic approach is crucial to avoid misdiagnosis and ensure a timely resolution, minimizing business impact. Correct approach analysis. The correct approach involves a multi-layered investigation, starting with the most probable causes and progressively moving to more complex ones. This aligns with best professional practices for troubleshooting. It begins with verifying the physical layer and basic network connectivity, then examines the IP telephony-specific configurations on the Cisco Unified Communications Manager, CUCM, and the endpoints, and finally delves into network traffic analysis. This methodical progression ensures that simpler, more common issues are ruled out first, saving time and resources. The focus on specific Cisco iOS commands and CUCM diagnostics reflects the expertise required for this certification and demonstrates adherence to industry-standard troubleshooting methodologies for Cisco IP telephony. Incorrect approaches analysis. One incorrect approach would be to immediately assume a hardware failure of the IP phones without sufficient evidence. This is a premature conclusion that bypasses critical diagnostic steps. Ethically, it leads to unnecessary replacement costs and potentially delays the resolution of the actual problem. It fails to follow a structured troubleshooting methodology. Another incorrect approach would be to solely focus on the CUCM configuration, ignoring potential network issues. While CUCM is central to IP telephony, audio dropouts are frequently caused by network congestion, CoS misconfigurations, or packet loss. Neglecting network diagnostics is a significant oversight and can lead to a prolonged outage. This approach is professionally deficient as it demonstrates a lack of comprehensive understanding of the interconnectedness of network and voice services. A third incorrect approach would be to randomly change settings on the CUCM or network devices without a clear hypothesis or documented baseline. This shotgun approach is inefficient and can introduce new problems, making the original issue even harder to diagnose. It violates the principle of controlled troubleshooting and can have unintended consequences on other services. Professional reasoning. When faced with intermittent audio quality issues, professionals should adopt a systematic troubleshooting framework. This involves 1. Understanding the scope and impact of the problem, 2. Gathering detailed information from users, 3. Verifying the physical and data link layers, 4. Examining device configurations, phones, CUCM, network devices, 5. Analyzing network performance and traffic, 6. Isolating the issue to a specific component or layer, 7. Implementing and testing a solution, 8. Documenting the findings and resolution. This structured approach ensures that all potential causes are considered logically and efficiently, leading to a more accurate diagnosis and a more robust solution. Question 5. The assessment process reveals that a group of users in a specific office location are experiencing intermittent audio degradation, including choppy voice and dropped calls, on their Cisco IP phones. The issue is not constant and appears to occur more frequently during peak business hours. Initial checks of the IP phone firmware and basic network connectivity for individual phones show no obvious configuration errors. What is the most effective next step to systematically troubleshoot this issue? Option A. Focus solely on the Cisco Unified Communications Manager, CUCM, call processing logs for any reported errors related to the affected phones. Option B. Reconfigure the voice VLAN settings on all network access points in the office to ensure proper traffic prioritization. Option C. Immediately replace the Cisco IP phones in the affected office with new units, assuming the phones themselves are faulty. Option D. Analyze network traffic patterns and quality of service. Co-S. Configurations on the switches and routers serving the affected office to identify potential congestion or packet loss. The correct answer is D. Analyze network traffic patterns and quality of service. Co-S. Configurations on the switches and routers serving the affected office to identify potential congestion or packet loss. Explanation. The assessment process reveals a common yet challenging scenario in IP telephony troubleshooting: intermittent call quality issues affecting a specific group of users. This is professionally challenging because the symptoms are vague, potentially affecting multiple layers of the network and application stack, and the impact on users can be disruptive to business operations. The intermittent nature makes it difficult to reproduce and isolate the root cause, requiring a systematic and thorough approach. The correct approach represents best professional practice because it prioritizes a structured, data-driven methodology aligned with industry best practices for troubleshooting. It begins with gathering comprehensive information from the affected users and then systematically moves through the OSI model, starting with the physical and data link layers, before progressing to network, transport, and application layers. This methodical progression ensures that simpler, more common issues are ruled out first, saving time and resources. It also aligns with the principles of efficient problem resolution, minimizing downtime and user impact. Furthermore, by documenting findings and actions, it contributes to knowledge-based development and future problem solving. An incorrect approach that focuses solely on the IP phone configuration without considering the underlying network infrastructure is professionally unacceptable. This fails to acknowledge that IP telephony quality is heavily dependent on network stability and performance. Such an approach could lead to misdiagnosis, wasted effort, and prolonged resolution times, directly impacting business continuity and user productivity. This also represents a failure to adhere to a systematic troubleshooting methodology, potentially violating service-level agreements, SLAs, and demonstrating a lack of professional diligence. Another incorrect approach that involves making broad, unverified changes to network device configurations, e.g., CO-S policies, without a clear hypothesis or supporting data is also professionally unacceptable. This is akin to shotgun troubleshooting and can introduce new problems or exacerbate existing ones, leading to further instability and a more complex troubleshooting environment. It demonstrates a lack of analytical rigor and a disregard for the potential negative consequences of undocumented or untested changes. This approach risks violating change management policies and could lead to significant network disruptions. The professional decision-making process for similar situations should involve 1. Clearly defining the problem and its impact. 2. Gathering all relevant information from affected parties and system logs. 3. Formulating a hypothesis based on the gathered information. 4. Developing a systematic troubleshooting plan, typically following a layered approach, e.g., OSI model. 5. Testing the hypothesis by implementing targeted diagnostic steps or changes. 6. Documenting all findings, actions, and results. 7. Escalating or seeking assistance if the problem cannot be resolved within the defined scope or time frame. 8. Verifying the resolution with the affected users. Question 6. Regulatory review indicates that intermittent audio degradation is being reported on Cisco IP phones across multiple sites. The issue is sporadic, affecting different users at different times, and is not consistently reproducible. The IT team needs to identify the root cause and implement a permanent solution. Which of the following approaches best aligns with professional troubleshooting, best practices, and regulatory expectations for service continuity? Option A. Advise users to try different codecs on their IP phones, suggesting that a codec mismatch might be the cause of the audio degradation. Option B. Instruct the help desk to log all user complaints and wait for a pattern to emerge or for the issue to become severe enough to be consistently reproduced before initiating any troubleshooting steps. Option C. Immediately access the Cisco Unified Communications Manager, CUCM, and review call processing logs, looking for any error messages related to media path failures or codec negotiation issues. Option D. Begin by examining the quality of service, CO-S, configurations on the core network routers and switches, and analyze network traffic patterns for packet loss, jitter, and latency impacting the IP phone traffic. Concurrently, verify the physical layer connectivity and port status for the affected IP phones. The correct answer is D. Begin by examining the quality of service, (CoS), configurations on the core network routers and switches, and analyze network traffic patterns for packet loss, jitter, and latency impacting the IP phone traffic. Concurrently, verify the physical layer connectivity and port status for the affected IP phones. Explanation: Scenario analysis. This scenario presents a common challenge in troubleshooting IP telephony and video systems, intermittent call quality issues that are difficult to reproduce and diagnose. The professional challenge lies in balancing the need for immediate resolution to restore service with the requirement to adhere to established troubleshooting methodologies and regulatory compliance. The intermittent nature of the problem makes it difficult to isolate the root cause, potentially leading to rushed decisions or the adoption of unverified solutions. Furthermore, the potential impact on business operations and customer satisfaction necessitates a systematic and documented approach. Correct approach analysis. The correct approach involves a systematic, layered troubleshooting methodology, starting with the most fundamental aspects of the network and progressively moving up the OSI model. This aligns with best professional practices for network troubleshooting, emphasizing data collection, hypothesis testing, and verification. Specifically, verifying the physical layer cabling port status, data link layer of LAN switch configurations, and network layer IP addressing routing (CoS) before examining application layer issues, codec negotiation, RTP streams is crucial. This methodical approach ensures that common, simpler issues are ruled out first, preventing unnecessary complexity and wasted effort. It also facilitates accurate documentation, which is vital for compliance, auditing, and future problem resolution. Adhering to this structured process minimizes the risk of introducing new problems and ensures that the resolution is robust and sustainable, thereby meeting service level agreements and potentially regulatory requirements for service availability. Incorrect approaches analysis, focusing solely on the Cisco Unified Communications Manager (CUCM) configuration without first verifying the underlying network infrastructure is a significant regulatory and ethical failure. This approach ignores the possibility that the issue might stem from network congestion, misconfigured CoS policies, or physical layer problems, which are often the root cause of intermittent call quality degradation. Such a narrow focus can lead to incorrect conclusions, wasted time, and potentially disruptive configuration changes on CUCM that do not address the actual problem. It violates the principle of efficient resource utilization and can lead to prolonged service disruption, impacting business operations and potentially violating service level agreements (SLAs) that may have regulatory implications. Implementing a quick fix by randomly adjusting codec settings on endpoints without proper analysis is also professionally unacceptable. This is a reactive, unscientific approach that bypasses the diagnostic process. It fails to identify the root cause and could lead to unintended consequences, such as compatibility issues or further degradation of call quality for other users. This approach demonstrates a lack of due diligence and can result in a temporary, superficial resolution that does not address the underlying problem, leading to recurring issues and potential noncompliance with service standards. Ignoring the problem until it becomes critical or a user escalates it significantly is a failure to uphold professional responsibility and can have severe regulatory and ethical ramifications. Proactive troubleshooting and timely resolution are expected. Delaying action can lead to significant business impact, customer dissatisfaction, and potential breaches of regulatory requirements related to service continuity or data integrity in communication systems. It also undermines the trust placed in the IT professional to maintain system stability and performance. Professional reasoning. Professionals should adopt a structured, data-driven troubleshooting methodology. This involves 1. Understanding the reported problem. Gather detailed information from the user about the symptoms, frequency, and affected parties. 2. Formulating hypotheses. Based on the symptoms, develop potential causes. 3. Testing hypotheses systematically. Start with the most likely and simplest causes, working through the OSI model. 4. Collecting and analyzing data. Utilize diagnostic tools, e.g., ping, traceroute, show commands, call detail records, network monitoring tools to gather evidence. 5. Implementing and verifying solutions. Apply changes methodically and confirm that the issue is resolved without introducing new problems. 6. Documenting the process. Record all steps taken, findings, and the final resolution for future reference and auditing. This approach ensures efficiency, accuracy, and compliance, minimizing risk and maximizing service availability. Question 7. The performance metrics show that a small group of users in a specific office location are experiencing intermittent audio degradation and dropped calls on their Cisco IP phones. The issue is not affecting all users in the office, nor is it a constant problem. What is the most effective initial troubleshooting approach to identify the root cause? Option A. Focus on verifying the physical and logical connectivity of the affected IP phones, including switch port status, VLAN assignments, power over Ethernet PoE status, and basic phone configuration settings. Option B. Advise the affected users to reboot their IP phones and report back if the issue persists without further immediate investigation. Option C. Initiate a broad network-wide quality of service (QoS) reconfiguration across all network segments to ensure optimal voice traffic prioritization. Option D. Immediately begin analyzing Cisco Unified Communications Manager (CUCM). Call detail records and trace files for the affected users to identify any signaling anomalies. The correct answer is D. Immediately begin analyzing Cisco Unified Communications Manager (CUCM). Call detail records and trace files for the affected users to identify any signaling anomalies. Explanation. Scenario analysis. This scenario presents a common but challenging troubleshooting situation in IP telephony. The intermittent nature of call quality degradation, affecting only a subset of users, makes pinpointing the root cause difficult. The challenge lies in distinguishing between network infrastructure issues, endpoint configuration problems, and potential application-level anomalies. A rushed or incomplete investigation could lead to incorrect remediation, wasted resources, and prolonged user dissatisfaction. The need for a systematic approach is paramount to ensure efficient and effective resolution. Correct approach analysis. The correct approach involves a methodical, layered investigation starting with the most probable causes and progressively moving to more complex ones. This aligns with best professional practices in IT troubleshooting, emphasizing a data-driven and evidence-based methodology. Specifically, beginning with verifying the configuration of the affected IP phones and their immediate network connectivity e.g., switch port status, VLAN assignment PoE is crucial. This is because misconfigurations at the endpoint or access layer are frequent culprits for localized issues. Following this, examining the call signaling path, e.g., SCCP/SIP messages, call setup failures, and then the media path, e.g., RTP streams, jitter, packet loss, provides a logical progression. This systematic approach minimizes the risk of overlooking simple solutions and ensures that resources are allocated efficiently. From a regulatory perspective, while no specific U.S. telephony regulations directly govern this troubleshooting process, adherence to industry best practices and service-level agreements, SLAs, with users or clients is implicitly expected. A thorough and documented troubleshooting process demonstrates due diligence and accountability. Incorrect approaches analysis. One incorrect approach is to immediately assume a widespread network congestion issue and begin making broad network changes without isolating the problem to the affected users. This is professionally unsound because it lacks a targeted investigation. It risks disrupting services for unaffected users and fails to address the specific symptoms. Ethically, it demonstrates a lack of due diligence and could lead to unnecessary downtime. Another incorrect approach is to focus solely on the Cisco Unified Communications Manager (CUCM) configuration without first verifying the physical and logical connectivity of the affected endpoints. While CUCM is central to IP telephony, issues at the access layer or with the phones themselves can manifest as call quality problems that are not directly caused by CUCM configuration errors. This approach is inefficient and can lead to misdiagnosis. A third incorrect approach is to dismiss the issue as user error or isolated endpoint failure without proper investigation. This is unprofessional and can lead to significant user frustration and a perception of poor support. It fails to acknowledge the possibility of a systemic issue affecting a group of users and neglects the responsibility to thoroughly investigate reported problems. Professional reasoning. Professionals should adopt a structured troubleshooting methodology, often referred to as the bottom-up or layered approach. This involves starting with the physical layer and progressing upwards through the network stack. Key steps include 1. Gathering detailed information about the problem. Who is affected? When does it occur? What are the specific symptoms? 2. Verifying endpoint status and connectivity. Check physical connections, PoE, switch port status, VLAN, and basic phone configuration. 3. Examining call signaling. Analyze SCCP/SIP messages for errors during call setup. 4. Investigating the media path. Monitor RTP streams for packet loss, jitter, and latency using tools like Cisco IP phones, built-in diagnostic tools, or network monitoring software. 5. Analyzing CUCM logs and configurations. Once endpoint and network path issues are ruled out, delve into CUCM for relevant call records and configuration checks. 6. Documenting all steps and findings. This is crucial for knowledge sharing, future reference, and demonstrating a thorough investigation. This systematic process ensures that the most likely causes are investigated first, leading to faster and more accurate resolutions while minimizing disruption. Question 8. The monitoring system demonstrates a recurring pattern of intermittent network connectivity issues affecting a Cisco IP phone deployment within a US-based healthcare organization. To diagnose the problem, a network administrator needs to access and analyze network traffic logs. Which of the following actions best aligns with U.S. regulatory requirements for data handling and incident response in a healthcare environment? Option A. Reconfigure the Cisco IP phones to disable all logging features temporarily to prevent log file corruption during the troubleshooting process. Option B. Access the network logs using administrative credentials without creating a separate incident ticket or documenting the access, as the issue is considered a routine technical problem. Option C. Immediately initiate a packet capture on the affected network segments, ensuring that all captured data is encrypted and stored in a secure, access-controlled location for later analysis, while also documenting the start and end times of the capture and the scope of the investigation. Option D. Purge all existing network logs from the past 48 hours to reduce the volume of data, and expedite the search for the specific error messages related to the connectivity issue. The correct answer is C. Immediately initiate a packet capture on the affected network segments, ensuring that all captured data is encrypted and stored in a secure, access-controlled location for later analysis, while also documenting the start and end times of the capture and the scope of the investigation. Explanation. The scenario presents a common challenge in IT environments, ensuring compliance with regulatory frameworks while troubleshooting technical issues. The core difficulty lies in balancing the immediate need to restore service with the long-term requirement of maintaining auditable records and adhering to data privacy regulations. Professionals must understand that technical solutions cannot operate in a vacuum. They must be implemented within a defined legal and ethical context. The correct approach demonstrates best professional practice by prioritizing the preservation of evidence and adherence to established protocols in the context of U.S. regulations, particularly those related to data privacy and security, such as HIPAA for healthcare or PCI DSS for payment card data, which often influence general IT practices. Maintaining the integrity of logs and audit trails is paramount. This ensures that any troubleshooting actions taken can be later reviewed for compliance, security, and accountability. Following established incident response procedures, which typically include evidence preservation, is a direct reflection of these regulatory expectations. An incorrect approach that involves immediately deleting or overriding logs to clean up the system fails to recognize the critical importance of audit trails. This action directly violates the principles of data integrity and accountability mandated by various U.S. regulations. Such a deletion could be interpreted as an attempt to conceal information, leading to severe penalties, including fines and legal repercussions. It also hinders any subsequent forensic analysis, making it impossible to determine the root cause of the issue or to identify any security breaches that may have occurred. Another incorrect approach, such as making undocumented changes to system configurations during troubleshooting, also presents significant regulatory and ethical failures. Without proper documentation, it becomes impossible to prove that the system was configured in a compliant manner or that troubleshooting steps did not inadvertently introduce new vulnerabilities or violate privacy policies. This lack of transparency is unacceptable under most regulatory frameworks that require clear auditability of system changes. It also undermines the principle of least privilege and can lead to unauthorized access or data exposure. The professional reasoning process for such situations should involve a clear understanding of the applicable regulatory landscape. Before initiating any troubleshooting, professionals should consult incident response plans and compliance guidelines. The decision-making framework should prioritize 1. Securing and preserving evidence logs, configurations, network traffic. 2. Following documented troubleshooting procedures that align with compliance requirements. 3. Documenting every step taken, including the rationale and outcome. 4. Consulting with compliance or legal teams if the troubleshooting process might impact sensitive data or violate regulations. This systematic approach ensures both technical efficacy and regulatory adherence. Question 9. Implementation of a new Cisco IP telephony and video solution in a U.S.-based financial services firm requires careful consideration of regulatory compliance. Which of the following troubleshooting approaches best aligns with U.S. regulatory frameworks governing data privacy and telecommunications? Option A. Proactively identify and integrate relevant U.S. data privacy and telecommunications regulations into the troubleshooting process, verifying that security controls for sensitive financial data are correctly implemented and functioning. Option B. Prioritize restoring full voice and video functionality immediately, addressing any potential compliance gaps only after the system is stable and operational. Option C. Assume that standard IT security best practices are sufficient for compliance, without specific verification of how they apply to the unique data types handled by IP telephony and video. Option D. Focus solely on network performance metrics and call quality, deferring any discussions about regulatory compliance to the IT security team at a later stage. The correct answer is B. Prioritize restoring full voice and video functionality immediately, addressing any potential compliance gaps only after the system is stable and operational. Explanation. Scenario analysis. This scenario presents a common challenge in IT environments where rapid deployment of new technologies, such as Cisco IP telephony and video solutions, must be balanced with adherence to established regulatory frameworks. The challenge lies in ensuring that the implementation, while meeting business needs for enhanced communication, does not inadvertently violate data privacy or security regulations. The complexity is amplified by the interconnected nature of IP telephony and video, which can carry sensitive personal and business information, making compliance a critical aspect of troubleshooting and deployment. Correct approach analysis. The correct approach involves proactively identifying and integrating relevant regulatory requirements into the design and troubleshooting phases. This means understanding how regulations like the U.S.'s Health Insurance Portability and Accountability Act, HIPAA, or the General Data Protection Regulation, GDPR, if applicable to the jurisdiction specified for the exam, which is U.S. for 300-080, might apply to the transmission and storage of voice and video data. For instance, if the IP telephony system is used in a healthcare setting, HIPAA mandates specific security and privacy controls for protected health information. 5. Troubleshooting must then consider whether these controls are correctly implemented and functioning. This approach ensures that the technology serves its purpose without creating legal or ethical liabilities, representing best professional practice by prioritizing compliance and risk mitigation. Incorrect approaches analysis. Implementing a solution without first assessing its compliance with relevant U.S. regulations, such as those governing data privacy and telecommunications, is a significant regulatory failure. This oversight can lead to substantial fines, reputational damage, and legal action. For example, deploying an IP video conferencing system that transmits unencrypted sensitive business data without considering the implications under U.S. federal or state data protection laws would be a direct violation. Another incorrect approach is to assume that standard IT security practices are sufficient without specific consideration for the unique data types handled by IP telephony and video, such as voice recordings or real-time video streams, which may have specific regulatory handling requirements. This demonstrates a lack of due diligence and a failure to understand the specific compliance landscape for the technology. Professional reasoning. Professionals should adopt a risk-based approach to troubleshooting and implementation. This involves 1. understanding the business context and the types of data being transmitted and stored. 2. Identifying all applicable regulatory frameworks based on the jurisdiction and industry. 3. Integrating compliance requirements into the design and configuration of the IP telephony and video systems from the outset. 4. During troubleshooting, verifying that implemented security and privacy controls align with regulatory mandates. 5. Documenting all compliance-related decisions and actions. This systematic process ensures that technical solutions are not only functional, but also legally and ethically sound. Question 10. Benchmark analysis indicates that intermittent call quality degradation is affecting a critical IP telephony deployment. The issue is not consistently reproducible, leading to user frustration and potential business impact. Which troubleshooting approach best balances the need for rapid resolution with minimizing further disruption and risk? Option A. Prioritize troubleshooting efforts based on a risk assessment of potential failure points and their impact on call quality and service availability. Option B. Randomly apply configuration changes to various IP telephony components until the issue is resolved. Option C. Focus exclusively on network infrastructure diagnostics, assuming all IP telephony issues stem from underlying network problems. Option D. Immediately begin reconfiguring the most complex call processing features, as these are often the source of subtle quality issues. Correct answer is A. Prioritize troubleshooting efforts based on a risk assessment of potential failure points and their impact on call quality and service availability. Explanation. Scenario analysis. This scenario presents a challenge in troubleshooting a critical IP telephony system where intermittent call quality issues are impacting business operations. The difficulty lies in the random nature of the problem, making it hard to replicate and diagnose. The pressure to restore full service quickly, coupled with the potential financial and reputational damage of prolonged downtime, necessitates a systematic and risk-aware approach. The technical complexity of IP telephony, involving multiple layers of network and application components, further complicates the troubleshooting process. Correct approach analysis. The correct approach involves a structured risk assessment to prioritize troubleshooting efforts. This means identifying the potential impact of different components or failure points on call quality, and then focusing on the areas that pose the greatest risk to service continuity and user experience. By understanding the potential consequences of each potential issue, e.g., a faulty codec configuration versus a minor network latency spike, the technician can allocate resources effectively. This aligns with best professional practices in IT service management, emphasizing proactive identification and mitigation of risks to ensure service availability and performance. From a regulatory perspective, while specific regulations for IP telephony troubleshooting are not explicitly detailed in the 300-080 exam context, the underlying principle of maintaining reliable communication services is often implicitly or explicitly covered by broader telecommunications or business continuity mandates. A risk-based approach ensures that the most critical functions are addressed first, minimizing potential regulatory noncompliance related to service disruption. Incorrect approaches analysis. One incorrect approach is to randomly attempt fixes without a clear diagnostic plan or risk assessment. This is professionally unacceptable because it is inefficient, potentially introduces new problems, and delays resolution. It fails to acknowledge the potential impact of different issues and could lead to addressing minor problems while a critical one persists, thereby increasing the overall risk to the business. Ethically, it demonstrates a lack of diligence and professionalism. Another incorrect approach is to focus solely on the most complex or technically interesting potential causes without considering their likelihood or impact. This can lead to wasting valuable time on obscure issues while overlooking simpler, more probable causes that are significantly impacting service. This approach is not risk-informed and can result in prolonged downtime, which could have implications for service-level agreements, SLAs, and potentially broader regulatory compliance if service availability is mandated. A third incorrect approach is to rely solely on automated diagnostic tools without human oversight and critical thinking. While tools are valuable, they may not always identify the root cause of intermittent or complex issues. Over-reliance on automation without a risk-based troubleshooting framework can lead to misdiagnosis and ineffective solutions, increasing the risk of continued service degradation. Professional reasoning. Professionals should approach troubleshooting by first understanding the business impact of the issue. This involves gathering information from users and stakeholders about the nature and frequency of the problem. Next, they should develop a hypothesis-driven troubleshooting plan, prioritizing potential causes based on their likelihood and potential impact risk assessment. This involves consulting documentation, network diagrams, and logs. The process should be iterative, with each step documented and validated. If a particular troubleshooting step does not yield results, the professional should reassess their hypotheses and adjust their plan accordingly, always keeping the overall risk to the service in mind. This systematic, risk-aware methodology ensures efficient problem resolution and minimizes disruption. Question 11. The efficiency study reveals a consistent pattern of intermittent audio degradation and dropped calls affecting a specific department's Cisco IP phones. The IT team suspects a network issue, but the problem is sporadic and difficult to replicate on demand. Which troubleshooting approach best aligns with professional best practices for resolving such complex IP telephony issues? Option A. Immediately replace all IP phones in the affected department, assuming hardware failure is the most probable cause due to the intermittent nature of the problem. Option B. Reboot all network switches and routers serving the affected department in a staggered fashion to clear any potential temporary glitches. Option C. Systematically analyze network traffic captures and device logs from the affected segment, correlating timestamps with reported incidents, and progressively isolate potential causes from the physical layer upwards. Option D. Escalate the issue directly to the Cisco TAC without performing any initial diagnostics or log analysis, as their expertise is required for such complex problems. The correct answer is C. Systematically analyze network traffic captures and device logs from the affected segment, correlating timestamps with reported incidents, and progressively isolate potential causes from the physical layer upwards. Explanation. The efficiency study reveals a recurring pattern of intermittent call drops and degraded audio quality on a Cisco IP telephony system within a large enterprise. This scenario is professionally challenging because it directly impacts business operations, customer satisfaction, and employee productivity. The pressure to resolve these issues quickly, while ensuring compliance with service-level agreements, SLAs, and potentially industry-specific regulations. Though none are specified for this exam's jurisdiction, best practice dictates adherence to internal policies and general telecommunications standards, requires a systematic and thorough troubleshooting approach. The complexity of IP telephony, involving multiple network layers, devices, and protocols, means that a superficial fix could mask underlying problems, leading to future recurrences. The correct approach represents best professional practice because it prioritizes a structured, data-driven methodology. This involves isolating the problem domain, gathering relevant logs and metrics, and systematically testing hypotheses. For example, starting with the physical layer and progressively moving up the OSI model, or a similar troubleshooting framework, ensures that fundamental issues are ruled out before investigating more complex software or configuration problems. This methodical approach minimizes the risk of introducing new errors and maximizes the chances of identifying the root cause. Adhering to established Cisco troubleshooting methodologies, which are designed for this purpose, is crucial for efficient and effective resolution. An incorrect approach that involves randomly rebooting network devices or IP phones without a clear hypothesis or understanding of the potential impact is professionally unacceptable. This can lead to unintended service disruptions, data loss, and a failure to identify the actual cause, thus wasting valuable time and resources. It also violates the principle of least disruption, a key tenet in IT operations. Another incorrect approach, such as immediately escalating the issue to a vendor without performing basic diagnostics, demonstrates a lack of ownership and troubleshooting expertise. This can result in delays, unnecessary costs, and a failure to develop internal problem-solving capabilities. Furthermore, making configuration changes without proper documentation or rollback plans introduces significant risk and can exacerbate the problem, leading to further service degradation and potential compliance breaches if service availability is mandated. Professionals should employ a decision-making framework that emphasizes systematic problem-solving. This involves 1. Problem definition, clearly understanding and documenting the symptoms. 2. Information gathering, collecting all relevant data, logs, network captures, device configurations, user reports. 3. Hypothesis generation, formulating educated guesses about the root cause based on the gathered data. 4. Hypothesis testing, designing and executing tests to validate or invalidate hypotheses. 5. Solution implementation, applying the identified fix. 6. Verification and monitoring, confirming the resolution and monitoring for recurrence. This structured approach ensures that troubleshooting efforts are focused, efficient, and lead to sustainable solutions. Question 12. Compliance review shows that intermittent audio degradation is being reported by users across multiple Cisco IP phones. The issue is not constant and appears to occur at random intervals. The network infrastructure includes Cisco routers, switches, and Cisco Unified Communications Manager, CUCM. What is the most effective initial troubleshooting approach to identify the root cause of this call quality degradation? Option A. Focus on analyzing the quality of service, CoS, configurations on the core network switches, assuming that voice traffic is being improperly prioritized. Option B. Begin by examining the physical layer and network connectivity for the affected IP phones and the network path between them and the CUCM, including checking for packet loss, jitter, and latency on the relevant network segments. Option C. Immediately investigate the Cisco Unified Communications Manager, CUCM, call processing logs for any error messages related to the affected calls, assuming the issue is with the call control signaling. Option D. Start by rebooting all Cisco IP phones experiencing the issue, as this often resolves transient software glitches. The correct answer is B. Begin by examining the physical layer and network connectivity for the affected IP phones and the network path between them and the CUCM, including checking for packet loss, jitter, and latency on the relevant network segments. Explanation. Scenario analysis. This scenario presents a common challenge in IP telephony troubleshooting: intermittent call quality issues that are difficult to reproduce and diagnose. The difficulty lies in the transient nature of the problem, making it hard to pinpoint the root cause. The pressure to restore service quickly, coupled with the potential impact on business operations, creates a challenging environment where hasty decisions can lead to further complications or noncompliance. Need to balance immediate resolution with adherence to established troubleshooting methodologies and potential regulatory guidelines. Though not explicitly detailed in the prompt, the exam context implies a need for structured, documented processes is paramount. Correct approach analysis. The correct approach involves a systematic, layered troubleshooting methodology, starting with the most likely and easily verifiable causes and progressing to more complex ones. This aligns with best practices for network troubleshooting, emphasizing data collection, hypothesis testing, and isolation of the problem. By beginning with the physical layer and network connectivity, then moving to IP and CoS configurations, and finally examining application-level issues, the engineer ensures that fundamental problems are ruled out first. This methodical process is crucial for efficient problem resolution and minimizes the risk of introducing new issues. It also supports documentation and audit trails, which are often implicitly required in professional IT environments, ensuring accountability and facilitating future problem solving. Incorrect approaches analysis. One incorrect approach involves immediately assuming a complex network configuration issue without verifying basic connectivity. This bypasses fundamental troubleshooting steps, wasting time and resources on potentially irrelevant areas. It can lead to overlooking simple physical layer problems like faulty cables or port issues, which are often the cause of intermittent problems. Ethically, this approach demonstrates a lack of discipline and adherence to structured problem solving, potentially leading to prolonged downtime and user dissatisfaction. Another incorrect approach is to focus solely on the Cisco Unified Communications Manager, CUCM, configuration without considering the underlying network infrastructure. While CUCM is central to IP telephony, call quality issues can originate from network congestion, routing problems, or CoS misconfigurations outside of CUCM direct control. Neglecting the network layer is a common pitfall that prolongs troubleshooting and can lead to incorrect conclusions about the cause of the problem. This approach fails to consider the interconnected nature of the IP telephony solution. A third incorrect approach is to make configuration changes reactively without understanding the impact or having a rollback plan. This is a high-risk strategy that can exacerbate the problem or introduce new, unforeseen issues. It lacks the systematic approach required for professional troubleshooting and can lead to significant service disruption. This approach is ethically questionable as it prioritizes speed over stability and careful consideration, potentially impacting a wider user base. Professional reasoning. Professionals should approach intermittent IP telephony issues by adopting a structured, evidence-based troubleshooting methodology. This involves 1. Understanding the reported symptoms thoroughly. 2. Formulating hypotheses based on the symptoms and system architecture. 3. Prioritizing hypotheses based on likelihood and ease of testing. 4. Systematically testing each hypothesis, starting with the most fundamental layers: physical, network connectivity, IP, CoS, and progressing upwards. 5. Collecting relevant data, logs, packet captures, performance metrics at each stage. 6. Isolating the problem to a specific component or configuration. 7. Implementing a solution with a clear rollback plan. 8. Verifying the resolution and documenting the process. This disciplined approach ensures efficient problem solving, minimizes risk, and upholds professional standards. Question 13. Investigation of a critical IP telephony call quality issue leads a Cisco technician to a customer's network. The customer, a senior executive, urgently requests the technician to bypass standard authentication procedures to access a specific network device, claiming it will expedite the resolution and prevent further disruption to their critical business operations. The technician is aware that these procedures are in place for security and auditing purposes. Option A. Politely refuse the executive's request, citing security protocols, and insist on following the standard authentication procedures, even if it causes further delay. Option B. Fabricate a justification for bypassing the authentication procedures to satisfy the executive's request and resolve the issue quickly. Option C. Escalate the request to a supervisor, explaining the customer's urgency and the requested bypass, and await further instruction while documenting the interaction. Option D. Immediately grant the executive's request to bypass standard authentication to expedite the troubleshooting process and resolve the call quality issue. Correct answer is C. Escalate the request to a supervisor, explaining the customer's urgency and the requested bypass, and await further instruction while documenting the interaction. Explanation. This scenario presents a professional challenge due to the potential conflict between a customer's immediate request and the established security protocols designed to protect the network and its users. The technician is tasked with troubleshooting a critical IP telephony issue, which inherently involves accessing sensitive network configurations and potentially user data. The customer's insistence on bypassing standard procedures, even with a plausible reason, introduces an ethical dilemma. The technician must balance the need for prompt service resolution with the imperative to uphold security and compliance. The correct approach represents best professional practice because it prioritizes adherence to established security policies and regulatory frameworks. Cisco's own best practices and the implied regulatory environment for IT service providers, which often mandate data privacy and security, require proper authorization and documentation before making any changes or granting access to sensitive systems. By escalating the issue to a supervisor and documenting the request, the technician ensures that the decision to deviate from protocol, if made, is authorized at the appropriate level and that a record exists for accountability and auditing purposes. This aligns with the principle of least privilege and the need for a clear audit trail, crucial for maintaining network integrity and complying with potential data protection regulations. An incorrect approach that involves immediately granting the customer's request without proper authorization or documentation would be professionally unacceptable. This failure constitutes a breach of security protocols and potentially violates regulatory requirements related to unauthorized access and data handling. It bypasses the necessary checks and balances designed to prevent malicious activity or accidental misconfiguration, exposing the organization to risks. Another incorrect approach, such as fabricating a justification to bypass the protocol, is ethically reprehensible and professionally damaging. This involves dishonesty and undermines the trust placed in the technician. It creates a false audit trail, making it impossible to accurately track system changes and potentially masking security vulnerabilities or policy violations. Such actions can lead to severe disciplinary consequences, including termination and reputational damage. The professional reasoning process for similar situations should involve a clear understanding of organizational policies and relevant regulatory guidelines. When faced with a request that conflicts with these, the technician should first attempt to educate the customer on the necessity of the procedures. If the customer remains insistent, the technician must escalate the request to a supervisor or designated authority. This escalation should include a clear explanation of the request, the reason for the deviation, and the potential risks involved. Documentation of all interactions and decisions is paramount. This systematic approach ensures that decisions are made with appropriate oversight, minimizing risk and maintaining compliance. Question 14. What factors determine the most efficient and effective approach to troubleshooting intermittent call quality issues in a Cisco IP telephony and video environment? Option A. The systematic application of a layered troubleshooting methodology, starting from the physical layer and progressing through network and application layers, informed by symptom analysis. Option B. Prioritizing troubleshooting efforts based solely on the most recent configuration changes made to the system. Option C. Randomly rebooting all network devices within the affected segment to clear potential transient issues. Option D. Implementing broad, system-wide quality of service (QoS) policy adjustments without initial fault isolation. Correct answer is A. The systematic application of a layered troubleshooting methodology, starting from the physical layer and progressing through network and application layers, informed by symptom analysis. Explanation. Scenario analysis. This scenario presents a common challenge in troubleshooting Cisco IP telephony and video environments, intermittent call quality issues that are difficult to reproduce and diagnose. The professional challenge lies in the need to balance rapid resolution with thorough investigation, ensuring that the chosen troubleshooting approach is efficient, effective, and adheres to best practices without causing further disruption. The pressure to restore service quickly can lead to hasty decisions, potentially overlooking root causes or implementing temporary fixes that mask underlying problems. The complexity of IP telephony and video systems, involving multiple network layers, devices, and protocols, further exacerbates this challenge, requiring a systematic and informed approach. Correct approach analysis. The correct approach involves a systematic, layered troubleshooting methodology, starting with the most fundamental aspects and progressively moving to more complex ones. This aligns with industry best practices and the principles of process optimization by ensuring that resources are applied efficiently. By beginning with physical layer checks, cabling, power, then moving to network layer, IP connectivity, QoS, and finally application layer, codec negotiation, device configuration, the process minimizes wasted effort and increases the probability of isolating the fault quickly. This methodical approach is crucial for maintaining service availability and user satisfaction, which are implicit operational requirements in any regulated telecommunications environment. It also supports compliance with service-level agreements, SLAs, by demonstrating a structured and accountable troubleshooting process. Incorrect approach is analysis. Focusing solely on the most recent configuration changes without a broader diagnostic sweep is an incorrect approach. This is a form of confirmation bias and can lead to overlooking other contributing factors, such as network congestion or hardware failures, that may have coincidentally occurred around the same time. Ethically, this approach risks a premature conclusion, potentially leading to an incomplete fix and repeated issues, which erodes customer trust and violates the implicit duty to provide reliable service. Implementing a broad set of network-wide QoS policy changes without first identifying the specific source of the degradation is also an incorrect approach. This is inefficient and can have unintended negative consequences on other services. It represents a failure in process optimization by applying a potentially disruptive solution without sufficient diagnostic evidence. From a regulatory perspective, such broad, unvalidated changes could inadvertently violate network performance standards or impact other critical communications, leading to non-compliance. Randomly rebooting all network devices in the affected segment is a brute force method that lacks a structured diagnostic process. While it might coincidentally resolve a temporary issue, it provides no insight into the root cause and is highly inefficient. This approach is professionally irresponsible as it introduces unnecessary downtime and risks further instability without a clear understanding of the problem. It fails to demonstrate due diligence in troubleshooting and could be seen as a dereliction of professional duty to diagnose and resolve issues systematically. Professional reasoning. Professionals should adopt a structured, evidence-based troubleshooting methodology. This involves 1. Understanding the reported problem thoroughly, including its scope, frequency, and impact. 2. Formulating hypotheses based on the symptoms. 3. Testing hypotheses systematically, starting with the most likely and fundamental causes. 4. Documenting all steps taken and observations made. 5. Escalating or seeking further assistance when necessary, providing clear and concise information. This process optimization ensures that troubleshooting efforts are focused, efficient, and lead to sustainable solutions, upholding professional standards and implicit regulatory expectations for service reliability. Question 15. When evaluating a recurring, intermittent issue where Cisco IP phones randomly lose audio during calls, and initial basic troubleshooting steps like rebooting phones and checking network connectivity have yielded no consistent resolution, what is the most effective process optimization strategy to identify and resolve the root cause? Option A. Initiate a deep packet inspection, DPI, analysis of network traffic during periods when the issue is reported to occur, correlating findings with specific phone models, call patterns, and network segments, and escalate to a specialized network analysis team with detailed findings if the initial analysis is inconclusive. Option B. Focus on updating the firmware on all Cisco IP phones to the latest version without further investigation, assuming a known bug in the current firmware is the cause. Option C. Advise users to avoid making calls during peak network hours and suggest they try calling again later, assuming the issue is related to network congestion. Option D. Immediately replace all affected Cisco IP phones with a different vendor's equipment to rule out hardware failure. The correct answer is A. Initiate a deep packet inspection, DPI, analysis of network traffic during periods when the issue is reported to occur, correlating findings with specific phone models, call patterns, and network segments, and escalate to a specialized network analysis team with detailed findings if the initial analysis is inconclusive. Explanation. The scenario presents a common challenge in IT troubleshooting, a recurring, intermittent issue that impacts user productivity and service availability. The professional challenge lies in efficiently diagnosing and resolving the problem without causing further disruption or violating service-level agreements, SLAs. The intermittent nature of the problem makes it difficult to reproduce and isolate, requiring a systematic and thorough approach. The correct approach represents best professional practice because it prioritizes a structured, data-driven methodology. By first gathering comprehensive information, including user reports, system logs, and network traffic captures, the technician can build a clear picture of the problem's scope and potential causes. Analyzing this data systematically allows for the identification of patterns and anomalies that might be missed with a less rigorous approach. Escalating to a higher tier of support with detailed documentation ensures that the problem is addressed by specialists with the appropriate expertise, further optimizing the resolution process and adhering to established support workflows. This aligns with professional ethical obligations to provide competent and efficient service, minimizing downtime and impact on users. An incorrect approach that focuses solely on immediate, superficial fixes without deep analysis is professionally unacceptable. This could involve simply rebooting devices or resetting configurations without understanding the root cause. Such actions may temporarily resolve the issue, but fail to address the underlying problem, leading to its recurrence and further user frustration. This demonstrates a lack of due diligence and can be seen as a failure to meet professional standards of care. Another incorrect approach, such as making broad system-wide changes without isolating the specific component or configuration causing the issue, carries significant risk. This could inadvertently introduce new problems or exacerbate existing ones, leading to wider service disruptions. This approach violates the principle of least privilege and careful change management, which are fundamental to maintaining system stability and security. A further incorrect approach might involve ignoring or downplaying user reports, assuming they are exaggerating or mistaken. This is ethically problematic as it dismisses the impact on users and can lead to a breakdown of trust. Professional IT support requires empathy and a commitment to understanding and resolving user-reported issues, regardless of their perceived severity. The professional decision-making process for similar situations should involve 1. Active listening and thorough information gathering from affected users. 2. Systematic log analysis and network monitoring to identify anomalies. 3. Hypothesis generation based on collected data. 4. Controlled testing of hypotheses starting with the least intrusive. 5. Documentation of all steps taken and their outcomes. 6. Appropriate escalation when initial troubleshooting is insufficient. 7. Clear and timely communication with affected parties. Question 16. The assessment process reveals that users are experiencing intermittent audio dropouts and choppy video during Cisco IP phone calls and video conferences. Network monitoring tools show occasional spikes in latency and packet loss on segments of the network connecting the IP phones and video endpoints to the core infrastructure. What is the most effective approach to diagnose and resolve this issue, considering the potential impact on business operations? Option A. Advise users to reduce their usage of video during calls and to speak more slowly to compensate for potential network issues. Option B. Immediately replace all affected IP phones and video endpoints, assuming they are the source of the audio and video degradation. Option C. Perform a factory reset on all network switches and routers in the path, without first collecting diagnostic data or identifying specific problematic devices. Option D. Systematically analyze network performance metrics, including latency, jitter, and packet loss, on the relevant network paths, and examine quality of service (QoS) configurations to ensure proper prioritization of voice and video traffic. The correct answer is D. Systematically analyze network performance metrics, including latency, jitter, and packet loss, on the relevant network paths, and examine quality of service (QoS) configurations to ensure proper prioritization of voice and video traffic. Explanation. The assessment process reveals a common challenge in troubleshooting Cisco IP telephony and video environments: the impact of network quality on user experience. Specifically, intermittent audio and video degradation, while seemingly a technical issue, often has significant implications for business operations and stakeholder satisfaction. The challenge lies in isolating the root cause, which could be anything from a faulty network device to a misconfigured quality of service, QoS, policy, or even an environmental factor affecting wireless performance. Stakeholders, such as end users and management, will focus on the symptom, poor call quality, and expect a swift resolution, often without understanding the underlying technical complexities. This requires the troubleshooter to not only possess deep technical knowledge, but also strong communication and analytical skills to manage expectations and provide clear explanations. The correct approach involves a systematic, data-driven troubleshooting methodology that prioritizes identifying and resolving the underlying network issues impacting voice and video traffic. This aligns with best professional practices by ensuring that solutions are not merely symptomatic, but address the root cause, leading to a stable and reliable communication system. Adhering to Cisco's recommended troubleshooting steps for IP telephony and video, which often involve analyzing network performance metrics, packet captures, and device configurations, is crucial. This methodical approach minimizes disruption, prevents recurrence, and demonstrates technical competence and accountability. An incorrect approach would be to immediately assume a hardware failure of the IP phones or video endpoints without thorough network investigation. This is professionally unacceptable because it bypasses critical diagnostic steps, potentially leading to unnecessary hardware replacement costs and prolonged downtime. It also fails to address the possibility that the network itself is the bottleneck or source of the problem, which is a common cause of poor IP telephony and video performance. Furthermore, it demonstrates a lack of systematic troubleshooting, which is a fundamental ethical expectation for IT professionals. Another incorrect approach would be to focus solely on user-reported symptoms without gathering objective network data. This can lead to anecdotal solutions that do not resolve the core issue and can create a perception of incompetence. It also fails to leverage the diagnostic tools and methodologies available for IP telephony and video troubleshooting, such as Cisco's own troubleshooting guides and network monitoring tools. This approach is ethically questionable, as it does not represent a diligent effort to resolve the problem effectively. A third incorrect approach would be to implement broad, unverified configuration changes across the network in an attempt to fix the problem. This is highly risky, as it can introduce new issues or exacerbate existing ones, leading to further instability and a more complex troubleshooting scenario. It also lacks the precision and targeted nature of effective troubleshooting, which is a hallmark of professional IT practice. The professional decision-making process for similar situations should involve 1. clearly defining the problem and its impact from a stakeholder perspective. 2. Gathering all available information, including user reports, system logs, and network performance data. 3. Formulating a hypothesis about the root cause. 4. Developing a systematic troubleshooting plan, prioritizing network-related issues for IP telephony and video. 5. Executing the plan methodically, documenting all steps and findings. 6. Communicating progress and findings clearly to stakeholders. 7. Verifying the resolution and implementing preventative measures. Question 17. The performance metrics show a consistent increase in jitter and packet loss on the IP telephony network during peak business hours, coinciding with user complaints of choppy audio and dropped calls. The network team has confirmed no significant bandwidth saturation or routing issues on the core network infrastructure. The IP telephony administrator needs to determine the most effective next step to isolate and resolve the issue. Option A. Escalate the issue to the network vendor for a complete network infrastructure overhaul, as the current metrics suggest a fundamental network instability. Option B. Analyze call detail records, CDR, and IP phone event logs for specific call failures, and correlate them with the timestamp performance metric spikes to identify patterns related to specific endpoints or call flows. Option C. Advise users to avoid making calls during peak hours until the issue can be fully investigated, as this will reduce the immediate impact on call quality. Option D. Immediately reconfigure quality of service, (QoS) policies on all network devices to prioritize voice traffic, assuming the metrics indicate a QoS problem. Correct answer is B. Analyze call detail records, CDR, and IP phone event logs for specific call failures, and correlate them with the timestamp performance metric spikes to identify patterns related to specific endpoints or call flows. Explanation. This scenario presents a common challenge in IP telephony troubleshooting: intermittent call quality issues that are difficult to replicate and diagnose. The difficulty lies in the transient nature of the problem, making it hard to capture definitive evidence and pinpoint the root cause. Stakeholders, including end users and management, expect a swift resolution, creating pressure to provide timely updates and solutions. The challenge is amplified by the need to balance immediate user impact with thorough, systematic troubleshooting that adheres to established best practices and potential regulatory compliance requirements related to service availability and quality. The correct approach focuses on a structured, data-driven investigation that prioritizes user experience while systematically eliminating potential causes. This involves leveraging available diagnostic tools, correlating performance metrics with user reports, and engaging relevant teams. This methodical process ensures that the troubleshooting is not only effective but also defensible, providing clear documentation of steps taken and findings. In the context of potential regulatory frameworks governing telecommunications service quality, though not explicitly detailed for this exam's jurisdiction, the principle of diligent service provision applies. This approach demonstrates a commitment to maintaining service standards and fulfilling service-level agreements. An incorrect approach that immediately jumps to a single, unverified solution without proper diagnosis risks misidentifying the problem, wasting resources, and potentially introducing new issues. This could lead to a failure to meet service expectations and, in a regulated environment, could be seen as a lack of due diligence in maintaining service quality. Another incorrect approach, such as delaying investigation until the problem becomes more severe, fails to address user impact proactively and can erode confidence in the IT department's ability to manage critical communication systems. This reactive stance is professionally unsound and can lead to greater disruption and dissatisfaction. Professionals should approach such situations by first gathering all available information, including user reports and system logs. They should then formulate a hypothesis and devise a plan to test it, starting with the most probable causes. Continuous communication with stakeholders, providing realistic timelines and updates, is crucial. If a definitive cause cannot be immediately identified, the focus should shift to implementing temporary workarounds while continuing the investigation. This systematic, documented, and communicative approach ensures that troubleshooting is efficient, effective, and professionally managed. Question 18. Cost-benefit analysis shows that a temporary workaround to restore voice services immediately would be faster and less resource-intensive than a full diagnostic investigation, but the risk of recurrence and potential security implications are significant. Given the critical nature of IP telephony for business operations, which troubleshooting approach best balances immediate needs with long-term system integrity and security? Option A. Initiate a comprehensive diagnostic process, analyzing logs, network traffic, and configuration across all relevant components to identify the root cause before implementing any permanent fix. Option B. Focus troubleshooting efforts solely on the end-user devices reporting the issue, as this is the most visible symptom of the problem. Option C. Implement a temporary workaround that bypasses the suspected faulty component, document the workaround, and schedule a full investigation during the next maintenance window. Option D. Immediately revert the system to its last known stable configuration, assuming the recent change caused the issue, and then investigate the failed change offline. Correct answer is C. Implement a temporary workaround that bypasses the suspected faulty component, document the workaround, and schedule a full investigation during the next maintenance window. Explanation. This scenario presents a common challenge in IP telephony troubleshooting, balancing immediate service restoration with long-term system stability and security. The professional challenge lies in making a rapid, informed decision under pressure, where a wrong choice could lead to prolonged downtime, data breaches, or non-compliance with industry standards. The need for a swift resolution is paramount, but it must not come at the expense of security or adherence to established best practices. The correct approach prioritizes a systematic, documented investigation that considers all potential root causes, including security vulnerabilities, before implementing a fix. This aligns with best practices for IT service management and cybersecurity, emphasizing a detect, diagnose, resolve, and prevent cycle. By thoroughly analyzing logs, network traffic, and configuration settings, the technician ensures that the underlying issue is understood and addressed, not just masked. This proactive stance minimizes the risk of recurrence and maintains the integrity of the IP telephony system, which is critical for business operations and potentially sensitive communications. Adherence to Cisco's recommended troubleshooting methodologies, which are implicitly part of the 300-080 exam scope, guides this systematic approach. An incorrect approach that immediately reverts to a previous, known good configuration without understanding the cause of the failure is professionally unacceptable. This bypasses the diagnostic process, potentially leaving a critical vulnerability unaddressed. If the original failure was due to a security exploit or a misconfiguration that was later corrected, reverting would reintroduce the problem or expose the system to further risk. This could lead to a violation of data protection regulations. If applicable to the jurisdiction, though not specified here, the principle of data integrity is universal, and a breach of service level agreements, SLAs, if the issue recurs. Another incorrect approach, focusing solely on the most visible symptom without investigating deeper network or application layer issues, is also professionally unsound. This quick-fix mentality often leads to transient solutions that fail to address the root cause. For example, simply restarting a service might resolve a temporary glitch, but would not fix an underlying configuration conflict or resource exhaustion that will inevitably lead to future failures. This approach lacks the diligence required for robust troubleshooting and can result in repeated service disruption, impacting user productivity and trust in the IP telephony system. The professional decision-making process for similar situations should involve a structured troubleshooting methodology. This includes 1. Clearly defining the problem and its impact. 2. Gathering information through observation, logging, and diagnostic tools. 3. Forming hypotheses about potential causes. 4. Testing hypotheses systematically. 5. Implementing a solution based on confirmed findings. And 6. Verifying the resolution and documenting the process and lessons learned. This framework ensures that decisions are data-driven, efficient, and contribute to the overall stability and security of the IT infrastructure. Question 19. The risk matrix shows a high-impact, high-probability scenario for intermittent audio degradation on Cisco IP phones across multiple departments. The current troubleshooting efforts have involved restarting individual phones and checking basic network connectivity, but the problem persists and appears to be random. What is the most appropriate next step to systematically diagnose and resolve this issue, adhering to best practices for IP telephony troubleshooting? Option A. Analyze call detail records, CDR, and IP phone logs for patterns related to the audio degradation, and investigate potential quality of service, QoS, misconfigurations on the network infrastructure. Option B. Isolate the affected departments by disabling their IP phone services temporarily until a definitive solution can be found. To prevent further user complaints, Option C. Consult online forums and community discussions for similar reported issues and apply any suggested quick fixes without further internal validation. Option D. Immediately schedule a firmware upgrade for all affected Cisco IP phones to the latest stable version, assuming a software bug is the most likely cause. The correct answer is A. Analyze call detail records (CDR) and IP phone logs for patterns related to the audio degradation and investigate potential quality of service (QoS) misconfigurations on the network infrastructure. Explanation: this scenario presents a common challenge in IT troubleshooting, a critical system failure impacting business operations, coupled with a lack of immediate clear root cause. The professional challenge lies in balancing the urgency of restoring service with the need for a systematic, documented, and compliant troubleshooting process. Rushing to a solution without proper validation or adherence to established procedures can lead to further complications, data integrity issues, or regulatory noncompliance. The correct approach represents best professional practice because it prioritizes a structured, evidence-based methodology. By systematically isolating the issue, consulting relevant documentation, like Cisco's troubleshooting guides for IP telephony and video, and collaborating with the appropriate teams, the technician ensures that the resolution is not only effective but also repeatable and auditable. This aligns with the principles of good IT governance and operational excellence, which are implicitly expected in professional environments and often underpin regulatory compliance in areas like service availability and data security. The focus on understanding the why behind the failure, rather than just the what, prevents recurrence and builds a more robust system. An incorrect approach that involves immediately rebooting all network devices without diagnosis is professionally unacceptable due to several potential regulatory and ethical failures. Firstly, it violates the principle of least privilege and unauthorized system changes, which can have security implications and may contravene IT policy. Secondly, it bypasses the required diagnostic steps, meaning the root cause remains unknown, increasing the risk of future, similar outages. This lack of due diligence can be seen as a failure to maintain service levels, potentially breaching service level agreements (SLAs), and leading to financial penalties or reputational damage. Furthermore, without proper documentation of the troubleshooting steps and the eventual fix, the organization may fail to meet audit requirements or demonstrate compliance with any relevant industry standards or regulations concerning IT service management. Another incorrect approach, such as relying solely on anecdotal evidence from colleagues without independent verification, is also professionally unsound. This introduces a high risk of misdiagnosis. If the anecdotal information is incorrect, the troubleshooting effort will be misdirected, wasting valuable time and resources and prolonging the outage. This can lead to a breach of operational efficiency and potentially impact business continuity, which may have regulatory implications depending on the industry. Ethically, it represents a failure to exercise professional judgment and due diligence. The professional reasoning framework to adopt in such situations involves a multi-step process. 1. Acknowledge and assess. Understand the impact and urgency of the issue. 2. Gather information, collect all available data, logs, and user reports. 3. Formulate hypotheses based on the information, develop potential causes. 4. Test hypotheses systematically. Implement diagnostic steps to confirm or refute each hypothesis, starting with the most probable or easiest to test. 5. Document everything. Record all actions taken, observation, and findings. 6. Escalate appropriately. Involve other teams or subject matter experts when necessary. 7. Resolve and verify. Implement the solution and confirm that the issue is fully resolved and that no new problems have been introduced. 8. Post-mortem and prevention. Analyze the root cause and implement measures to prevent recurrence. This structured approach ensures that troubleshooting is efficient, effective, and compliant. Question 20. Market research demonstrates that intermittent audio degradation in Cisco IP telephony deployments is a persistent concern for organizations. A user reports experiencing occasional choppy audio during calls, but the issue is not constant and disappears when the user is moved to a different desk. The network team has confirmed no widespread network outages or high utilization. What is the most effective and professionally responsible troubleshooting approach to identify and resolve the root cause of this user's specific issue? Option A. Immediately reconfigure the quality of service (QoS) settings on the core network switches, assuming that is the most likely cause of all audio degradation. Option B. Systematically isolate the issue by examining the user's specific IP phone configuration, the cabling to their desk, and the switch port they are connected to, while also reviewing QoS settings on the local switch and the path to the call control server for any anomalies affecting that specific port or device. Option C. Advise the user to simply restart their IP phone whenever the issue occurs, as this often resolves temporary glitches. Option D. Document the user's complaint but wait for the issue to become more frequent, or for multiple users to report similar problems before initiating a detailed investigation. The correct answer is B. Systematically isolate the issue by examining the user's specific IP phone configuration, the cabling to their desk, and the switch port they are connected to, while also reviewing QoS settings on the local switch and the path to the call control server for any anomalies affecting that specific port or device. Explanation. This scenario presents a common challenge in IP telephony troubleshooting: intermittent call quality issues that are difficult to reproduce and diagnose. The professional challenge lies in balancing the need for immediate resolution with the requirement to adhere to established troubleshooting methodologies and documentation standards, all within the context of the 300-080 exam's implied regulatory framework, which, for this exam, is assumed to be general IT best practices and Cisco's recommended procedures. As no specific jurisdiction is provided, pressure to restore service quickly can lead to shortcuts that compromise thoroughness and future maintainability. The correct approach represents best professional practice because it systematically isolates the problem by gathering detailed information, leveraging diagnostic tools, and testing hypotheses in a controlled manner. This aligns with the principles of efficient and effective troubleshooting, minimizing the risk of introducing new issues and ensuring a permanent fix. It also implicitly supports the need for accurate documentation, which is crucial for knowledge sharing, future problem solving, and compliance with any organizational IT governance policies. An incorrect approach that focuses solely on restarting services without proper diagnosis fails to address the root cause. This is professionally unacceptable because it is a temporary fix at best and can mask underlying network or configuration problems, leading to recurring issues and increased downtime. It also bypasses the opportunity to learn from the incident and improve system resilience. Another incorrect approach that involves making configuration changes based on assumptions without verification is also professionally unacceptable. This introduces significant risk. It can lead to unintended consequences, further degrading service or causing complete outages. It violates the principle of controlled change management and can be ethically questionable if it impacts user productivity or data integrity without due diligence. A third incorrect approach that involves ignoring the issue until it becomes critical is professionally unacceptable. This demonstrates a lack of proactivity and responsibility. It allows potential problems to escalate, leading to more significant disruptions, greater repair costs, and potential damage to the organization's reputation or user trust. It also fails to meet the implicit ethical obligation to maintain a functional and reliable communication system. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the reported problem thoroughly. 2. Gather all available data, logs, user reports, network status. 3. Formulate a hypothesis about the root cause. 4. Plan and execute diagnostic steps to validate or refute the hypothesis. 5. Implement a solution based on validated findings. 6. Test the solution thoroughly. 7. Document the problem, solution, and any lessons learned. 8. Escalate if the problem is beyond the scope of current expertise or resources.